This is the first in the series of 4 videos about Mathematica. In this video, I'm going to talk about the basics of Mathematica, how it works, and then we'll do some simple algebra and some plotting, one of the first commands. One of the nice things about Mathematica is that it builds on itself. That is, you can learn just some very basic stuff and be fine, and then as you get to more advanced stuff, you can just do that as needed. You don't need to learn the whole program at once to be able to use it. Mathematica can be very complex. Very advanced mathematics can be done with it. But whether or not you learn all those commands now or ever is really up to you. Start with the basic stuff, get used to it, think of it as a big calculator, and then add to your repertoire as time goes on. What you're looking at right here is a Mathematica notebook. A notebook is a program. It's also the file that we save. So here we have a file. It's untitled right now. That means it's not been saved. You can see there's a bunch of commands at the top. These are all drop downs. So file, edit, etc. All you see here right now is this big cursor across the top. This horizontal line tells us that we are ready to input some information in a new cell. We'll talk about cells in a little bit. So for example, if I just type a number, let's say 3, right now nothing's happened. So this is what's called the front end. Your notebook is just the front end. This is all the information that you've saved. Mathematica hasn't done anything with it yet, and when it does do something, that's going to happen in the back end, or what's referred to as the kernel. And how you get Mathematica to do something, to actually evaluate your work, is not enter, because enter is just a carriage return in Mathematica, but shift enter. That is, hold the shift and the enter key down at the same time. And if you do that, you'll see here that we get 3 as my output. A couple of things going on right now. First, you'll see that Mathematica tells you what's input and what's output. 3 was my input, and it tells me right here that the input was 3 and my output is also 3. The 1 means this is my first input and my first output. You also heard a beep. Why was there a beep? Because I haven't saved my notebook, and if you haven't saved your work, Mathematica is going to beep at you every single time you run a line to remind you to save your work. So I'm going to do that right now. I'm going to save this file as Mathematica number 1. So we'll just go here to save, and you can see here now I've renamed this as Mathematica Notebook 1. So now when I run a command, it's not going to beep at me. If I do some basic math, it's just like a calculator. I can do 3 plus 5, shift enter, and it's going to tell me 8. And we can divide and we can multiply just like you would expect. Let's go into some algebra. How do I define constants and variables? So a constant, you just tell it what it's equal to. So for example, if I want a to be 7, I'll just type a equals 7 and shift enter. And let's let b be equal to 9. So now Mathematica knows that a is 7 and b is 9, and it repeated it back to me. If you don't like those repeats, you can put a semicolon at the end of any line and it won't repeat back any output. So for example, if I let c be 15 and then put a semicolon and do shift enter, it's just going to say fine, it's going to give me the input, but it's not going to give me the output, although you can see here it says suppressed output. If I click on show output, it will repeat back the 15. Not very interesting. So now if I say what is a plus b, it says 16, input and output. Notice again that my line numbers are going up. So this was input and output 6. I can go out of order in the notebook. Once things have been learned by Mathematica in the kernel, they are learned. So if I come back up here, before I've designated A and B, it doesn't matter because the output has already been done. So here, if I say A times C, and the times symbol coming from above the 8, shift enter, 105. It's okay that it's out of order. Now let's go back to the kernel for a second. All of what you have seen here is happening in my front end. What you see here is your piece of paper, if you will. All the actual evaluations are happening in the kernel. I can get rid of my output, and the way I do that is go to Cell, delete all output. But you'll notice the input lines are still the same. Nothing has been deleted except for the output. So the information and the calculations are all still there. So if I still say A divided by C, it'll give me an answer. On the other hand, if I quit the kernel, and that is if I go to evaluation, all the way at the bottom, there's a thing that says quit kernel and local. It's going to ask me if I really want to do it. I'll say yes. Notice now all of my input lines have gone to stars. They have lost their number. So now if I go in the order that's written and I do 3, Shift Enter, it takes a second because it's restarting the kernel. There was actually a command that said start kernel. Generally, you don't need to use it. Anytime you do Shift Enter, it will restart the kernel. And now I say A times C, and it's just going to say A space C. The space is an equivalent for multiplication. Why didn't it remember that C was 15? Well, because I quit the kernel, and therefore all of that knowledge was gone. So we've done some basic algebra right now. Let's talk about creating a function, which is also very important. How do you create a function? This is syntax heavy, so you have to be careful. It is not f parentheses of x anymore. In Mathematica, it's f bracket. Now, Mathematica is giving me this command. You can't see it down here, and it just says, hey, by the way, I am going to give you the matching close bracket here just so that you don't make a mistake. You can turn this off if you want. And now this seems to say f of x, but not quite yet. To get f of x in Mathematica, I need an underscore after the very first and only the very first x. So here I am telling Mathematica I'm about to define f of x. And I'm going to let this equal to x squared. So here I use the caret that's above the 6. There's also a shortcut to make it a little exponent, and I'll show you that later. And Shift Enter, and again it's going to repeat back x squared. Notice it will allow me to plot this and do some calculus on this immediately, but we're not going to do that yet. If you forget the underscore here, things can get bad fast. And you might start getting errors coming up because you've forgotten the underscore. If that happens, no worries. Just quit the kernel, put the underscore back in, and then run things as you had planned. So quitting the kernel is a really nice way of fixing when Mathematica has gone a little bit off the rails. Usually there's a fault in your notebook. Remember though, when you quit the kernel, you're not deleting any of your work. You'll lose your work if you don't save it, but quitting the kernel is not going to do it. All right, let's actually plot x squared now. Let's plot this function. Now I could just click plot and it'll do it. There's a plot, but let's actually go through what this command looks like. So let's just pretend I want to plot something different than x squared. So I'm going to start typing plot. You'll notice that Mathematica has got predictive capabilities. So it starts looking at different things that start with PLO. And there's plot, there's three-dimensional plotting, plot range, plot style, etc. Those are commands within the plot function to make your plots look better. So let's type plot here. And actually, I'm just going to click on plot. And you'll notice there are two possibilities here. This double caret and the I. The I will give you information. It's the help file. So if I click on that, what's going to pop up, here's my plot information. It's going to show you the different types of plots. It's going to give you some examples. Unfortunately, Mathematica, because it's such a complex program, a lot of times the examples are actually quite complex. And then down here, it's going to give you all the different options that you have. Again, we will get into some of these later. Many of them we'll never get into. But if you are interested, you can always just come and maybe learn something new here. Shows you how to do some really cool stuff. What was the other thing? So if we click on plot, you'll notice that there was this double caret. If I click on the double caret, what it's going to give me is the different types of plot commands. And so if you don't remember the format, the syntax of it, they're here. So if I click on one of them, you'll see it gives me the template on how to do a plot. So f is the function. Now we could use f of x, which I've already defined, so I could actually just type f of x. Don't need the underscore here. The underscore is just for defining it. Now this part here is going to tell Mathematica what values of x do you want to actually evaluate this from. So x You're actually telling it what the variable is. If I had done f of y or f of z, then I would type z here. It's not always x. It just has to match whatever independent variable you're using here. And your lowest value, let's say -2, and my upper value, let's say 4. And if I do Shift Enter, there is my plot. But I could do any kind of plot. So I could just say plot, and we'll do the same thing here. We'll have it fill in. We'll do something in terms of z. So we'll do z cubed minus 5, and we'll let z go from -1 to 1. And it looks like that. Notice here that Mathematica is trying to show you what's most interesting, and this is not the x, or technically the z-axis. We're at -3.8 or so, 3.9. If you want to change that so that you tell Mathematica, hey, what specific y values I want, here it gave me my z values, my independent variable values. If you want to change the y values, the output values, you add what's called a plot range. So you can see here plot style. Plot style will show me different colors, etc. I'll do that next. But plot range, all, I'm not really sure what that does, but we're going to just do brace. And in Mathematica, lists are in braces. Like here, this is a list of 3 items. They're in braces. And we're going to say that y, remember input is z, output is y, will go from -6 to 1. So now there's going to be a lot of blank space here because I'm going to go up to y equals 1. And so you can see here I've defined what my picture looks like. The -1 to 1 is where I'm plotting it, and here tells me what you want to see. That's sort of the graph paper that I'm using. I can actually change the plot range of the x values or z values here if I want as well. So I could say, let's show me a range of -2 to 2, again in braces. Now this whole thing needs to be in braces because it's one big list defining my plot range. And the first group here is my z values, and these are my y values. And so now z is going from -2 to 2, even though I'm only evaluating between -1 and 1, and my y values are going from -6 to 1. The last thing I want to show you here is how to add a little bit of style to this. We're not going to do a lot, but if you add the command plot style, it's right there, and it says, gives you the arrow. You can see I can do some things here. I can make it gray, I can make it dashed, I can make it thick, and if you put them in braces, you can do several things at once. So for example, I'm going to make this red, and I'm going to make it thick. So this is in brace. So these commands are in braces, and when I do Shift Enter, you can see I have turned my plot red and made it a little bit thicker. And you can actually define how thick you want that to be. That's it for your basic algebra and your basic plotting command. These are 2 things that are really going to get you pretty far in Mathematica, at least to start with. I want to add one quick thing before I wrap this up. And I want to talk about what Mathematica gives as an output. So I'm going to create a new function. We're going to call it g of x underscore to create the function. And I'm going to let that equal to the cube root of x. So x to the power of 1/3. Okay, so I've defined this function. Again, I could put a semicolon at the end if I don't want it to repeat out x to the 1/3. So I put a semicolon here and then do Shift Enter. It's still defining the function. It just didn't repeat out that as an output. And so, for example, if I say, what is g of 8? 2, which is what we expect. The question is, what happens if I say, what's g of 9? And the answer is going to be, it's just 3 to the 2/3. Notice that it's not going to give me a decimal answer here because Mathematica is always going to try and give you the most exact answer as possible. And 3 to the 2/3 is the most exact answer. That may not be helpful to you if you want a decimal answer. So let's say you actually do want a decimal answer. There are several ways to do this. The easiest way is to add an n command around your command here. So n, capital N, says give me a numerical answer. And commands in Mathematica, which I'll talk about more in the next video, are always brackets. So n bracket, and then I want g of 9. So this says give me a numerical value for g of 9, and it's going to give it to me here in 5 decimal places. You can set how many decimal places you want. In fact, you can see down here, show all digits or give the integer part, etc. So this is one way of doing it. Another way of doing it, all commands can be repeated by just doing a / at the end. So if I could say g of 9 and then do / capital N, that's just a shortcut way of saying do the numerical value of g of 9. And then the last way is if you introduce a decimal point into any part of a command, then Mathematica believes that you want decimal answers. So if I say what's g of 9 decimal, even with nothing after that, Mathematica now thinks that you want an answer in decimal form, and so it's going to give it to you in decimal form. But if you don't add that, or if you don't do the n, everything that you put as an input, it's going to come out as exact. So one last example here, if I say, for example, sine of 30, now Mathematica is thinking in radians. So I don't know what the sine of 30 radians are. I know the sine of 30 degrees is a half, but sine of 30 radians I don't know, and if I do shift enter, it just comes back and says sine of 30. That's as exact as you can get. If I say sine of 30 degrees, and you can just type in a degree symbol, which is escape, the escape key, type in DEG and escape. Now it's 30 degrees and do shift enter, it's going to tell you 1/2. And if I do the exact same thing and do / n, it's going to come out as 0.5. Notice it doesn't give me all those trailing zeros because you don't need them. All right, that's a lot we've accomplished in this one video. So try and take this in, some really basic stuff. The next video is going to walk you through some other simple commands that'll really get you started with Mathematica. But right now you should be able to do some simple arithmetic, set up a function, do some basic algebra. Then we'll do some commands. This will be a much shorter video. And then you'll be ready to go with Mathematica. And then the next 2 videos after that will be for advanced users.